Okay, good morning everyone. Welcome to the continuing webinar series we have for the American Council of Independent Laboratories. What I have shown on the screen for the webinar is the announcement we put out back in January, and we have done this now for even the 2015 as well. And if I scroll down, you'll see that there's many webinars, and what I try to do is to inform the ACIO members of what is happening in the electromagnetic compatibility standards area. There's many major committees that meet, and you can see by just looking at it, I even get into some of the technical management at the U.S. National Committee of the International Electrotechnical Commission. So we're right now at 16 November, and my subject for this time is to review the annual CISPR, which is the International Special Committee on Radio Perturbations. Most people call it radio interference. It's French, that's why it doesn't go in the sequence of CISPR. And it was held in Germany, in Frankfurt, actually, it was just 3 or 4 weeks ago. So this is the second week in November right now, and I'm going to move on to start that. You notice we have one left, and that is the Advisory Committee on EMC, which I will hold a webinar at 11 a.m. Eastern Standard Time on 7 December. All of these webinars are recorded. In fact, the recording is going on right now as we speak, and there is access to them by ACIL members for no charge through the website, and for those that are not, they are charged a nominal fee. So with that, I'm going to close that window and show you what I'm going to be referring to as we go along. What I like to do is look at the agenda for these meetings and then describe a little bit what's going on. The CISPR meeting, for example, is a 2-week meeting, and it was in Hangzhou, China. But what I'm showing you is the plenary agenda, which is the plenary for all of CISPR and its subcommittees, and that is probably the best way to look at the overall activity and action that occurred. So as usual, we have a intellectual property policy, much like we do when we have anything from ACIL. We have any meetings, they have to do that. And let me continue on with the agenda. You notice we have documents that we bring up, and we have discussion leaders. Usually it's myself as chairman or my secretary, and then we have individuals. The purpose on the right is whether we need to make a decision or it's just for information or put on record, and that is what we do. All this information is only available to National Committee members, and it is stored on the IEC website with password protection. So what I'm showing you now is what I can show you, obviously live, but I can't give you the document. So let's move on to agenda item 4. We had minutes of the last meeting, which I don't propose to bring up. The last meeting was in Stresa, Italy, last year, and these meetings of the plenary is once a year. The meetings of the subcommittees can also be once a year, but sometimes they have meetings in between. There are webinars that are held by the management committee, which is called the steering committee, every month, but I'm not going to get into that kind of detail here. Matters arising, what I'm going to do is just sort of bring things up a little bit at a time. The thing that I wanted to show here is that we really do work. These are the action items that came out of 1 year ago, and you notice the green comment. Everything is closed before this meeting. That's one of the things I insist upon. Don't wait a year to do something. Get something done, and I'm fortunate that the members of the plenary, which are national committee delegates, This year we had 21 countries, so there'd be 21 heads of delegation, and they bring along their delegation. And this year there was about 220, a little bit over 220 members that are part of the delegation, but normally only about 100 show up because the others are going to the subcommittees themselves. So let me close this down and continue on in the item number 6, because I've already done the action items, which you can see are pretty well closed, except for some that it's not worth discussing at this particular webinar. There is a report from the technical officer. This is from the IEC central office in Geneva, Switzerland, and it may be worthwhile to go through a little bit of the facts. This is key information. There's 20,000 people working in the IEC standardization, and you can look at the numbers there. The important number is the number of technical committees and subcommittees is quite large, 177 of them, of which CISPR has about 8, and the number of active projects is close to 2,000. So it is a very robust and active IEC. Then what we ask from the central office, anything that we know in handling our own standardization, and so I'm going to go fairly quickly through it. The one thing is someone said, well, it has to be done in 3 months. Well, there's some months that have 31 days, some months have 28 days, some months have 30 days, so they just simply put it now in weeks, and that's what that says. And this is the types of documents and their voting period or their comment period. NP is a new proposal, new work item proposal, and it could be 4 weeks for comments back, or if you have something attached to it, like as it shows, a draft or an outline of a draft. But if there's just an idea of something you want, then one national committee is proposing without that kind of backup, then it's a full 12 weeks. And note that these documents are usually translated, into the common language. And if we're talking about 21 countries, you can see it takes time to do that translation, albeit most can understand English even though it's not their native language. CD is committee draft. There's a choice depending on the amount of material. CDB is a committee draft with vote. This is a voting document, and there's only one time that's allowed. And FDIS is final draft international standard, and that's a 6 weeks voting, and that's a yes/no type vote. Then there's some technical reports, technical specification, DTS, technical reports, publicly available specifications, questionnaires, documents for comments, all have their own amount of soak time, so to speak, with the national committees before they have to respond. All right. Don't want to talk about that. It just says if you have more than one TC, then you have to have an election. There was a lot of work by the central office to remove countries, there's well over 100 countries in the IEC, if they don't participate, and there's rules. Participation means voting on documents, having at least one representative on a committee, and so forth. And if they're not following those rules, the central office says so, and they might demote them to O member where they don't have a vote. And for some countries that's important, that they want to have the ability to vote yes or no. There's editing rules I really don't want to go over, and there's a lot of websites that talk about to put together a good document so it's readable in there. So there's a URLs that you would bring up, but again, I don't want to go into that. Code of conduct. This is the first time there's been a big push on that. And the last two, patent and copyright issues, have been around for quite some time, intellectual property. But now they're getting more down into how are you using or misusing social media, for example, and the actual conduct in a meeting. These are guidelines, obviously, but it's important to get the work done. And here's what they think participation is. There's a work going on with young professionals, and now it's young professional. You see the second bullet item there. The definition is from early 20s to mid 30s. So there's roughly 10 to 15 years there, and they're essentially new to the job. And the IEC has been nurturing the use of, the suggestion and nomination by the National Committee. And for example, the U.S. National Committee has in past proposed up to 7 YPs to be considered as their view of someone that can take over when many of us are long since out of the committees. And you can see some statistics there. Over 300 participants from 44 countries. And then there's a bunch of tools that I don't want to spend time on. So we asked the central office to get us up to date, and you can see the effort. So if you're a secretary of a committee or an editor, a lot of the things on that I showed you is important. Otherwise, it gets bogged down and doesn't get published, and that's hardly useful as a tool for customer success. Now, we had a lot of organizational changes this year, primarily because there's a 9-year term limit, and many were in that 9-year, including myself. In fact, I'll just bring mine up and just to show you the document that went out. In accordance with the supplement right, the nomination of Ms. Bettina Funk as chair of CISPR starts the 1st of November. In fact, it's right now. My term ended the 31st of October. Bettina is a lady from Swedish Telecom. She is quite new, well, not new to standardization, but she's in her mid-30s, so she would qualify as a young professional. So there's a sort of a sea change, and I've been working with her as needed because the past chairs serve on the steering committee, which she now is in charge of. And you can see 14 agreed, 2 did not, and number of committees that could have voted were 23 national committees. Okay, so let me close that down. I won't open up the others because they simply say the names of those that are taking place with Subcommittee A, which is on measurement, instrumentation, and methods, Subcommittee H, and generic emission, Subcommittee I, multimedia, and receivers, and so forth. We also have joint working groups within CISPR, and let me just show you that real quickly. 1335, and we have actually rules on how you operate a joint. You'll find everyone needs rules, and I'm not even going to stop and read any of it. But the point is, if it's a joint effort, who's in charge, who is the administrator, how is it published, under whose banner, and what is here is something that fell out of work that was done probably 12, 13 years ago when Peter Carey was the chair of CISPR, and I took over from him in 2007. So let me close that out. There is, I will just say this, that the Advisory Committee on EMC is another major part of the IEC structure on EMC. If you look at the top, it's the General Secretary of the IEC, and underneath that is the Standardization Management Board, and they manage all of the technical committee in the IEC, of which CISPR is one of the technical committees. And underneath that is advisory committees, and ASEC stands for the Advisory Committee on EMC, and that means they want us to be their support. And of course, I'm also chairman of ASEC. There are many technical committees that have EMC in their operation or in their documentation, more than just CISPR and TC77, which many of you may know does most of the immunity work, although emissions below 9 kilohertz as well. We have a tracking sheet. I don't want to bring that up because I want to get to some more detail. What we do is look at the projects and we ask, is there a customer? And if, let's say, subcommittee A has a basic measurement method, and if there's no product committee, subcommittee, B on ISM and I on multimedia, for example, then we don't support it, because it was probably someone's idea, but if there's no customer, we have very limited resources, and we keep track of it with these tracking sheets. New technology, this is always an interesting comment. Let's say, I'm just thinking back when nanotechnology was first introduced in EMC application. How would you introduce that into CISPR? And right now we have two. If you look at 7.8 there, just the title. One is a study group 10. It's actually a special group 10 on wearable devices, where the electronics is worn next to the body. And the other one is ACART, Advisory Committee on Robotic Technology, and those are new. And the question is, how do we in the IEC EMC world handle that, in particular CISPR? And you can imagine a robotic that interferes with other robots, or they are not immune to emissions from a nearby source of energy. So we joined up to at least be recognized that we're a player if there's interference. Because again, CISPR whole life is to control the emissions such that the radio services are protected without interference. And the radio services start at 9 kilohertz, and believe it or not, they go over 400 gigahertz. And someone said, well, do you really have anything, let's say, below 150 kilohertz? And the answer is yes. There's a lot of time signals, radio time signals, so at countries around the world. And those are radio services, and CISPR has to protect them by making sure products don't emit excessively to interfere with the normal operation of those timing signals, for example. So let's continue on. One of the issues we always talk about lately is, and I'll leave the one on dated references later, because it's, as you might imagine, if it's dated, you have to follow that version. If it's undated, you have to follow the latest one. And if you don't have control over that standard in your committee, then it can get out of sync, and you may not want to use the latest version. So that's essentially a short description of what's happening there. But I would like to open up the 9 to 150 kilohertz region. There's several things I want to talk about there. It's a hot topic. Just a little bit of a background. 77A is low frequency, and working group A is just one of the working groups. The question that has caused all this interest in the frequency range shown is, there is, for example, the smart grid operation, the meters and the communication channel tend to operate in that frequency range, roughly around 80 kilohertz, by the way. And there are grid-connected inverters, power inverters, namely if you look at the brick that's powering your laptop, that is sending harmonics and other signals back into the mains. And everyone works on an AC-DC converter, all electronics. I can't really think of much that doesn't. And there's billions of those there with a B. So the question is, from the metrology people that want to have a good signal-to-noise ratio, putting power line communications on the power line to serve to implement the smart grid concept, they would like to have as low a noise as possible so they can get as high a signal-to-noise ratio as possible. Well, something has to give. The grid-connected power inverters are on the line, which is, as I said, billions of them. They have to, in fact, exist. In fact, they've existed for quite some time. And you aren't going to ask them to put a filter on every single converter, AC-DC converter that exists. You're talking billions of filters. So they have a certain level of noise they put on the line, and the metrology people have to realize that if they're going to get a signal noise ratio, they may need a higher signal, but now you're getting into the sense of that signal, which is the actual signal delivered across both the legs of the power line. That may be converted with the unbalance of the power line into longitudinal signal, and guess what? All longitudinal signals are effective antennas radiating or being a receiving antenna. So that now gets into the situation where CISPR is very concerned, because obviously we want to protect the radio services, and if there's a high signal that's been converted into a common mode on both of the conductors of the AC mains, that is an antenna radiating, even though it's a magnetic field in general, but that still could interfere with radio services. And I already mentioned such things as timing signals, clock signals around the world. So the question is there a compatibility level? Well, Subcommittee 77A, which is again low frequency, was tasked to try to come up with something, and the document I'm showing in front of you is the give and take back and forth of the questions we asked, and it turns out that they have a solution, they believe, in the 9 kilohertz to 30 kilohertz region, but there's widely divergence of what to do between 30 kilohertz and 150 kilohertz, and there's no answer yet. And that's really on the minds of the Standardization Management Board that says, fix it type of thing. And ASEC gets involved because we are advisory and they comment on our comments. So what I'm showing you here without reading it is a give and take back and forth between CISPR and 77. For example, question 2, we wanted to know what is the longitudinal conversion loss. In other words, the conversion of a signal to common mode. And to be frank with you, you can put any number you want in there, because the power line, the mains, is not a balanced system. It wasn't intended to be balanced at 50, 60 hertz. So, and we're talking about kilohertzes. And that's the rub. Because even if we knew the signal of the signal noise ratio needed, we wouldn't know how to compute what would show up on common mode, because we needed this conversion factor, which if you had to measure it, you would be the rest of your life measuring it, because every power system has something different. So what we did here, we gave them essentially the equations, but we don't have any data, and they don't either. So just trying to set the tone of why there is questions of what to do in the 9 kilohertz to 150 kilohertz, because even if you could measure it, you have to have limits, and there are no limits except for some products such as induction cookers, which doesn't necessarily apply to a general limit in that frequency range. And and there you have a problem, because you need the limits, you need the method of measurement, you need the qualification of the site in which you're going to make these measurements. You got to go into measurement uncertainty, and the list just continues on. And this is a gritty problem. By the way, that working group has over 50 people on it trying to solve this, and all I say is we're keeping tune of what's happening, but the bottom line is, the last CISPR comment there, perfect symmetry cannot be assumed. If it's perfect symmetry, of course, nothing is converted into longitudinal. And therefore, it's advisable to measure some values. But in the last meeting, we came to the conclusion, if you measure on your power line, then you measure on your power line, and you pick 50 others, there's going to be a statistical distribution, but I wouldn't even guess what the mean value of that longitudinal conversion loss would be. So this is a hot topic around the world, folks. I'm glad I was able to fill you in on what's recently happening. Let me close this down. Boom. Next hot topic, wireless power transfer. Everyone loves wireless power transfer. So it's a convenience. You know, your Apple notebook, you can, or even any kind of portable smartphone, you'd like to lay it down on a charger and pick it up later on fully charged without having to make a connection metallically. Okay, let's take that, and you're talking about milliwatts there. Now let's take it to the extreme. I'm going to make the same statement for charging an electric vehicle. Now you're talking about 10, 20 kilowatts, and the frequencies they've been picking out has been roughly in the 70 to 90 kilohertz region. And that then goes back to Gen IM 8.2, what's happening in that frequency range. So they're all starting to interact together, and there was a presentation here, let me open this up, by the subcommittee that deals with it. It's a very short one, and I think it's useful. Look at this figure. When you say wireless power transfer, then I have to ask the question, how is the mechanism to do that transfer? Is it inductive, capacitive, some kind of microwave transfer? Is it infrared? Because these are all wireless transfer systems. And most people work with the inductive transfer, which is essentially an open air core transformer with a primary and a secondary, and then worry about the magnetic field coupling. But look at all the others that could be in effect. So there are two documents in CISPR, CISPR 14.1, CISPR 15. 14.1 is appliances, CISPR 15 is lighting, and again, he was giving a little background here of the main issues of how do you handle it's more than just inductive coupling, it's capacitive, the figure before. 14.1 has a task force, and they're up with a maintenance cycle, and they want to have a committee draft, which is their first view of what should be considered as limits and methods of measurement by the end of January, 2 months from now. In 14.1 and 14.2 are sort of a pair. I don't want to go into that detail. CISPR 15, the lighting part of it is they have a CD and is included in a committee draft they're working on already for the 9th edition of the document, and that has a target date. Look at the target date for publication, 2 years from now. So the question will immediately be raised, well, wait a minute, we have a problem now, what can we do now? But as you might imagine, the sort of sea change or inclusion of additional or widening of the scope, you just don't do that overnight when you got 20 countries and let's say 30 people representing those countries, all with ideas of how it should be done. Of course, the new content, though, is they're trying to use the existing limits for magnetic field, and again, you can see the induction cooking there. That's been argued, but it's at least a starting point. And then, of course, how do you go through the modes of operation of this inductive power transfer? In fact, how would you even make a test bed? For example, you're not going to, for an electric vehicle, you're not going to have a car as part of your dummy load, so to speak. So they're working on the equivalent of what the car would look like, at low frequency, at 30 to 50 kilohertz. Not easy, not easy. And of course, that's the end of his talk, which was really to get us interested in some of the detail and what's happening in CISPR to alleviate that. So let's move on then to environmental definitions. Well, I really don't want to bring that up. The area is how do you handle commercial and light industry, because most of the limits for emissions are for residential and industrial environments. And if you do, why are you doing that? And switch right to the bottom line. Everyone simply says we only want 2 sets of limits, and we'll see how those 2 other environments fit in, which is good news because we don't need another set of limits, because then you start scratching your head, well, which one applies? Because I'm in a commercial area, but I have a residential product, and vice versa, and you can see the difficulty would come up. So I'm not going to bring up definitions. I want to get to some of the committee talks. I give a report, and I think, let me just bring it up very short. It's a brief report, but we held a meeting at Hangzhou. That's how it's pronounced, Hangzhou, not Chow. And there is all of the product committees you see there: industrial, scientific and medical, automotive, appliances, generic limits, multimedia, receivers. And the point of this slide is just to show in the blue font the changes that went into effect the 1st of November, which was 10 days ago or 15 days ago. So I'm no longer chair. We have a lot of people on the steering committee, and we have international representation from ITU, International Telecommunication Union, the radio sector, the amateur radio, international. We have European broadcast. You can read the list yourself, and that's what makes CISPR a special committee, because all the other technical committees have national committees only, one committee, one country. Whereas in CISPR we have the same, but we also have these others shown that have rights to participate in our work, and hence special committee. We'll pass some of this stuff. And you can see, I tried to show the things we did on webinars in between the 2 annual meetings, and we've been talking about. Here's the work on the compatibility level. Here's the work we did on wireless power transfer. The second big bullet item down there is our thrust into robotic technology. And then I think I'll just stop at this point. We have a lot of liaison reports because we want to, we're more than just national committees. And then we have joint task forces, which I'm not going to bring about. In this slide, there's a lot of links on the IEC webpage for all the things we do in CISPR, and it's kind of useful. There's a zone right on the IEC homepage, and I just showed a screen capture on the right, and there's another one. So the point is, I try to tell the delegates where they can find what we've been working on at a policy level, for example, and it's all there. The ASEC report, I only want to bring up one thing to show you the extent beyond CISPR. Let me bring up. Okay, this one may be an eye chart, but look at the reports that we get. 77, obviously in CISPR, they're obvious. TC8 on electrical energy supply. 13 on metrology. 22 on the, essentially the grid-connected power supplies. 46 cables. 61 household electrical appliances. 62 medical devices. 65A industrial process control. 69 is the electric vehicle. We even get into human exposure, TC106. Why? Because they measure an electric or magnetic or electromagnetic field. Well, we do the same thing in CISPR, but in TC106 to go the next step to see the penetration into the human, and therefore they call that specific absorption rate, and that's the critical thing as far as safety to human health. So that's all I want to do there, and let's go on to the next. don't want to bring up the working group reports. We have a strategic business plan. And by the way, it's quite extensive. Let me bring it up because everyone has to have a strategic business plan. But I'm just going to go through the titles as we scroll along here. This is what we have to produce to this standardization management board to show what we do. Well, there's some of the obvious things such as who we are, which is right there in paragraph A. And it's a good read, Barry. This is public information, by the way. Then we have the management structure, and this is how we handle subcommittees, task groups, and maintenance teams. And there are names there of the conveners. You can see CISPR's got a lot of stuff going on. The one on the left is Subcommittee A, which is the basic standards. They have 16 documents, 17 now, that describe measurement instrumentation, measurement methods, statistical application, including measurement uncertainty, and so forth. And the other product committees, which are the committees on the further to the right, would use the basic information and apply it to their specific product. For example, if it's industrial, scientific, and medical, you would use the paragraphs that say how you make an emission measurement, but in the document for the product committee, it would show the test setup, and that would change for all of the product committees and what modes of operations, etc. So let me go through that briefly. We have to talk about the business environment, and as you imagine, what you'll see in here without reading it is that most of our standards are captured by regulatory authorities and become requirements, and therefore we have a very strong sense of duty to do the right thing. Now, that depends on the country and how they adopt it. Sometimes they make a country standard that's identical to the CISPR standard. But for example, in the European Union, they may make common modifications, such as more applicable to 50 hertz than 60 hertz, but the basic document would be a CISPR. And usually what they do, they put an EN 550 in front of the CISPR publication number. So CISPR 32 on multimedia emissions would be EN 55032. And until you make that harmonized standard in the European Union, it's not you can't use it to show conformity to the EMC directive, which is now, of course, embroiled in the radio equipment directives, so-called RED directive. Market demand, well, I've already kind of touched upon that. And our customers are regulatory authorities, technical university. You can read that list. There isn't much that's not there, including practicing test labs, third from the bottom, huh? Trends in technology, well, we always talk about the smart grid and things that are coming down the pipe that we know of. Electric vehicles, sure, wireless power transfer. We kind of gone through this already. And then changes in technology, if there are any, that are major. Robotics is going to be one. LED lights and the interference it causes is another. It just cropped up. And again, I just kind of system approach. The IEC is very much interested in not having silos where one technical committee does just one thing and they don't apply it to other product committees. And CISPR is in a very unique position where, in fact, we do that because we have product committees. And I think that's really all I want to say. And then there's a list of all of our standards work. So let me close that. And move down to liaison reports. Now, there's a lot of reports there. I'm just going to show one or two with the time we have available. Let's pick up the one from the International Telecommunications Union radio. And Mr. Kubota always gives us a good presentation. But the thing just to recognize as I go quickly through these is that a lot of the work that's going in the ITU, which, as you know, is a treaty organization, when a recommendation comes out of the ITU, it has to be implemented by all the signatory countries. So that is a direct, well, you might call it a regulatory group, even though they call them to call the output recommendations, but it's more than recommendations. So I'm just going to look at the contents without going into it. They're into wireless power transfer as well. They have several study groups that work in this area. The World Radio Congress was coming up in 2019, and that's where they talk about what they've done since the last WRC. And I really am, as you walk through here, the blue was meant to be how they're highlighting, and you can see in this slide the second bullet item is wireless power transfer, and I'm just looking as we go along. Working Party 1A is worried about the revision of, well, if you look at it, they speak about, in this case, technical report on wireless power transfer. So wireless power transfer is in a lot of places. This is an interesting slide that I think I could spend an hour talking about it, and I won't. But it's their view of how they fit into the world of WPT. And this further states how they do it. And you can see the conclusions here is you know, they like to maintain a good relationship with CISPR on WPT, which you can see at the first bullet item. They're interested in what's going on in WPT below 300 kilohertz. Well, we already talked about we are interested below 150 because we don't have a standard set of limits other than for specific product application below 150 kilohertz, because everyone's kind of familiar. We start at 150 with measurements on the power line, the mains. We never went down below 150, so that's kind of a new challenge, so to speak. So then we have a discussion with the gentleman and ask questions back and forth, which is quite good. Let me just pick one or two others here to, and I have to admit I have to open it up myself. Yeah, this is ECMA International. It used to be called the European Computer Manufacturers Association, but they went to an acronym like, you know, the Radio Corporation of America went to RCA, for example. They are very much into information and technology equipment, and let me go down to their interest is particularly in what's happening in Subcommittee I, in particular CISPR 32, which is, again, emission measurements for multimedia receivers and so forth, and IT stuff. So if you look at the second paragraph, their Technical Committee 20 strongly suggests that CISPR thinks about an update process for guaranteed minimum stability periods. So their concern of their membership is they don't want to have a revision of a standard out in 2 years when they're just getting used to implementing it. And as a consequence, most of our standards, except for the basics in Subcommittee A, measurement methods, etc., they have a stability period of about 3 years, a minimum of 3 years, and some have even gone as far as make it at 4 years. And this would have answered ECMA's comment on that. CISPR 35 is the immunity side of that has been published on, again, multimedia, receivers, and IT. And the big issue there is that there are existing standards like 13 is emission and 22 is emission and went to 32. But on the immunity side, CISPR 20 that applied to receivers and CISPR 24 that applied to information technology is going to be replaced by CISPR 35, which is already published, and in fact, the second edition is being prepared as we speak. They are concerned about when the original documents are going to be withdrawn, and you only use CISPR 32 and 35. And of course, only use means a regulatory authority can say that. All of our CISPR standards, in fact, all international standards work is voluntary. If you want to use it and make a requirement, that's up to you. But as far as we're concerned in writing the standards, they are all voluntary. And in fact, as you can see with the common modifications in the European community, they may use as a strong basis a CISPR document, maybe 90% of it, but they still would have common modifications as it would apply to the European Union regional area. And that's the choice of the regulators, not us writing a standard. And I think that's all I want to talk about on ECMA International. Let's bring up another here, because we're getting, okay, where's my mouse? It's somewhere here. Oh, here it is. Where did the mouse go? This is the European Telecommunications Standards Institute. I just wanted to point it out that you can see Bettina Funk was the representative, and now she named somebody else as she moved up to chair. And they do a lot of work on radio spectrum. In other words, CISPR doesn't get into radio transmitters. If you have a transmitter, it has a microprocessor-based transmitter would go by its own fundamental and spurious requirements that are not set by CISPR. And CISPR would then be interested in the incidental emissions from the power supply and the electronics. So in that case, you would have to meet two requirements, one for the radio part and one for the incidental radiator part. And again, these are very sort of an eye chart here. But I just wanted to show some of the titles as we go along. And this is way too much to get into with the time we have left. But I want to show you that, and see, here's their concern and their interest in the scopes of 32 and 35. They want to make sure there's no conflict and so forth. And that's obviously a good thing not to have. Let's see what else I want to go through. There was a report from TC77 I think is worthwhile to bring up. This is done by the Secretary, Klaus-Peter Bretz, good friend of mine. And there's the scope, which I don't think I have to go into detail. There's the three subcommittees that are key here. Everyone's probably familiar with A on the harmonics, B on the 61000-4-X series, and probably not on C, which is high power transients, such as the electromagnetic pulse, for example. And there's a lot of documents that they talk about. One thing that's nice about some of these, the 2-5 in particular, describes the RF environment as particular separation from a broad variety of transmitters. And that would help setting test levels for radiated immunity testing, for example. Again, I'm just going to go. So what I do normally when I have more time on another webinar, I go into a little bit more detail of what is happening to each one of these documents one at a time. And here there's one line that says something's happening. For example, 4-3, 61000-4-3. Extension up to 6 gigahertz to kind of be a companion pair to the emission standards in CISPR, which go up to 6 gigahertz. And by the way, there's a mulling around again of CISPR going higher than 6 gigahertz. It was a discussion with our decision at the Hangzhou meeting. And of course, we in the FCC world have always at least looked at or see if there's any emissions up to 40 gigahertz. And even 40 gigahertz is not high enough. There's work going on at 60, 100, and even over 100 gigahertz. Talk about instrumentation nightmare. So here's the people that do it. You see Working Group 8, that's the one that's doing the compatibility levels. Luc Berthaud from France is in charge of that. And again, I'm not, 77A is again the harmonics. And you can see they get into quite a bit more, which we just don't have time to cover here. And here's what was the review of what's happening in the 2 to 150 kilohertz region. You can see consensus up to 30 kilohertz, but there's not consensus between 30 and 150, and that's important because the wireless power transfer works in that area as well as the smart grid. And I won't go into the details, but if you look at that oval, that circle there, you can see the desperate difference between, and we're talking about tens of dBs in some cases. So this is going to take a continuing work. And I don't think I need to go into this. Of course, we always ask them if they give something, what's the communication with us? And I've already gone into the compatibility. That's what CL stands for, compatibility levels. So we've already covered that. And then we have joint task forces with 77, and the two that are most active are on transverse electromagnetic, TEM cells as a measurement method up to the gigahertz region, and then reverberation application, and those are moving forward for both emission and immunity, radiated emission, radiated immunity aspects and application. So we have people from both of the committees, because 77 generally is the immunity side, and CISPR would be the emission side. And I think that's all I really want to get into here. But you can see there's a lot of work going on in 77 as well as CISPR. And I think that's all we have time for right now. I'm just going to see what I can do with the time we had left. Japanese National Committee on item 14 there, they presented a paper, well actually a PowerPoint, of doing pre-compliance work with either computation or some other method before you do a compliance test. In other words, they're trying to get something at the design level. This is an interesting topic, but we haven't gone anything further with that. But I think it's worth, maybe I'll at least bring it up because it may be something that the Chinese further, let's go back here. So it's called pre-assessment method, and he talks about several things, and the idea is not assessment by a test. That's the key. It's by analysis of the design and with the expectation that it will presume, not presume is probably the wrong word, but it may give a better idea of performance when it is tested for compliance. And I won't go into detail, but it was an interesting view of life. What do we need? They're trying to say that it's the difference between a black box test or a test in which they know something more about it. And some good graphics here. See, if the design is known on the left, they don't need to know that there would be a problem because it's going through the circuit board, whether it's an ESD event, for example. But on the right, if it's built the right way, that energy will be shunted to maybe a ground and not go through the printer, and therefore they have different reliability, so to speak, as it shows there. And I'm just seeing if there's anything that I could talk about a little bit more. It was extensive, and I think let me just move on to near the end. Well, this is sort of the flow chart. There's a design. Go to this pre-assessment condition. You look at the output of it, and if you see something that has a high risk, like I just showed you in that one example, going through the printed wiring board, you would then redesign it. If not, then it's ready to do a test, and then of course report the results. So I think you get the gist of what they're trying to say, and we don't do this in CISPR. We don't get into the design level. Obviously, for good EMC, you have to do that. So I'm not sure where this is going, but they pointed out some of the things in our scope that seems to facilitate going with this approach, and so forth. By the way, their standards are GB in nature, and so their proposal is to develop a standard. And frankly, any national committee has the right to do that. But I think what will happen is we'll have to put together what they call a new work item proposal, an NP, to see if other national committees think this is worthwhile. Thought that was an interesting concept. Now we're getting down to near the end. I asked, in fact we are at near the end, Subcommittee F that does work on lighting, I always ask one of the subcommittees to do a little more detail. This isn't a very long presentation, but it gives you an idea of what they do in Subcommittee F. And the scope is, you can read it, is not limited, but here's the thing they handle: appliances, kitchen, white appliances, which is washing machine, dryers, toys, power tools, lighting and similar equipment. Some people didn't realize we have a product committee, and there's a list of figures of what that might be. And then they have two major standards, 14 and 15. The 14 does more of the appliances, 15 does more of lighting. And lighting, not lightning, it's lighting, LEDs, incandescents, and so forth. Because they're also helping manufacturers, they have used what we call an 80-80 rule, which says 80% of the product line will comply if it's within 80% of the limit and things like that. But that's a regulatory statement, and we have it as information for manufacturers if they're doing sampling, but it's not meant to do the final test, which is usually a product. You do it with one version of the product. And we'll go through all the details here. There's the rogues gallery of who's there, and the person on the left is Stefan Kloska. He's very good. He's from Germany. I was very impressed how he's got his handle around the technology and being able to run the committee. Last thing I think will be good for me as well is I gave a presentation over what happened in my 9 years with the chairing CISPR, and there's a few there. The photograph in front of you, I'm on the left. Dr. Ralph Showers is in the center. He was past chairman in the 80s. Peter Carey from the UK was my predecessor, and this was at the Sydney 2007, which is the first meeting I took over. These are all the places that I chaired meetings for 2-week meetings, and you look at it's throughout the world. We're very proud of the fact that we go where we give every country the opportunity to host and move it around the world, which you can see by all those locations. I put it for fun who was at the meeting in Sydney. I don't propose to look at it, but interesting to note in the far right there, I was the U.S. head of delegation back in those days. This is just a number of meetings that have occurred. And the subject we review in the steering committee, which is the the management of the plenary is pretty much what we've kind of gone over with the business plan. So I don't propose to go in that, but I wanted to summarize that. And between 2008 and 2016, there were 280 separate topics covering those 8 or 9 bullet items. That's the intensity of the amount of work we've done over that period of time. And here's some things that we accomplished. And I just put some of it together. A lot of it is management. We got the joint task forces together with 77. We have webinars that keep the work flowing now. We have worked with the advisory committee on EMC, which, by the way, is the subject of the next webinar. And we had some limited success. We didn't quite get where we wanted to with power line communications, but nonetheless, I thank everybody for the 9 years I was able to work, and they helping me work over that period of time. So with that, I think I've covered sufficiently what we talked about and where the action is and the hot topics from CISPR's plenary that was held in Hangzhou, China, the last week in October and the first week of November 2016. And with that, I'm going to call a conclusion and an end to the webinar. Our next meeting will be in Vladivostok, Russia, in the same time frame a year from now. And we'll see what happens there, but that will be under the new chairmanship of Bettina Funk. So with that, I close the webinar.